What's up, everyone? Today we are going to talk about titrations. So, this is the general setup for a titration. You've got some lab equipment that we may not have seen before. The main one being a burette, and we'll be using an Erlenmeyer flask as well. So, let's go over a bunch of key terms. What is a titration? It's a method for determining the concentration of an unknown acid or base using a neutralization reaction. So that'll involve both an acid and a base. We need a titrant, which is the solution of known concentration, and an analyte, which is the unknown. This is what we're trying to figure out. Okay, and it's based off the idea that when you have the same number of moles and acids, it's going to eventually reach this equivalence point. Okay. So usually the titrant is going to go in your burette, whereas the unknown generally goes in the Erlenmeyer flask here. When can you tell when the reaction is done? Well, we're going to use an indicator to help us predict when the reaction is finished. So remember, for a strong acid and a strong base, the pH is going to be 7. They're going to neutralize each other, at which point we reach the equivalence point. The end point is when the indicator changes color. So if you use a good indicator for your titration, the end point will be the same as the equivalence point. And so here we're using phenolphthalein. Okay. And so this is just an example of what a titration would look like. Basically, we just barely want to get that phenolphthalein to show. And so looking at this graph, you can kind of see the progress of a titration. I'm going to change this to red. So basically, we slowly add base to our solution, and that's going to increase the pH. Once we get to this area here, it becomes really sensitive, right? Where the pH jumps really high if you just add one little tiny drop of base. And so you're trying your best to reach this equivalence point here, where the pH is equal to 7. And so if you add just a little tiny drop after that, you'll be able to see this pink color, right, the phenolphthalein. And so we'll do a little titration virtual lab together on Friday where you can see all of this happening. Okay, so again, more on this later. Don't worry so much about the setup right now. All right, but we will be focusing on solving titration problems today. So one is using stoichiometry. So that's the coefficients and balancing equations. The other thing you need to know how to do is use this equation. And so remember, M is concentration. V, of course, is volume. And N is going to be number of moles. Okay. All right, we'll do two examples together. So first, what is the concentration of HCl? Okay, so it might be a good idea to write down the given information. I don't know the concentration of acid. Remember, HCl is an acid. If 30 milliliters of 0.1 molar NaOH, so I've got my concentration of base is 0.10 molar. I've got my volume of base, 30 milliliters, neutralizes 50 milliliters of HCl, and that's my volume of acid. Okay, the moles of acid and moles of base, I'm going to look at the chemical equation for that. And so here, the moles come from the coefficients. I have one of each, so when I write and plug this into the equation, I can basically ignore that because it's just one. So now we have all our numbers. We can go ahead and plug into our equation here. So I'm going to do exactly that. So Ma, I don't know, 50 milliliters equal to 0.1 m times 30 milliliters. We can ignore the Na and the Nb here because it's just 1. We're going to solve for Ma by dividing both sides by 50. and we end up with 0.06 molar. Concentration should be in capital M, molarity. And there you have it. That's how you solve these titration problems. Let's take a look at a second example. This time we have 20 milliliters of base. So again, good idea to just write down your given information. Sorry, that should be volume. Is neutralized after 25 milliliters of standard acid is added. So I've got my volume of acid is 25 milliliters, and I've got my concentration of acid. So remember, the standard solution is the one that you know the concentration of. I don't know the concentration of my base here. All right, what is the concentration of base? Okay. I also want to include the moles of acid, so I have to look at the equation here, and this time I have 2 moles of acid for every 1 mole of base. So one thing I want to point out is that you basically, forever how many OHs you have, you're going to have the same number of hydrogens. And that's why there's a 2 there. Well, more on that later. For now, we can just plug it into our equation here. MAVA over N equals MBVB over MB. So I'm going to plug in all these numbers, and I've got 0.05 M times 25 milliliters over 2 equal to MB. I'm solving for concentration every time. 20 milliliters over 1. So I'm just not gonna not write it. Well, why not? Okay, so if I want to solve for MB, I'm simply going to divide both sides by 20. So I've got 20 milliliters here, 20 milliliters over here. These will cancel out, and I just have to plug all this in. 0.05 times 25 divided by 2 times 20, and I end up with this answer, 0.03 M. All right, so try the practice problems on your own, and we'll continue doing more of these titration problems